Hi guys, good evening. So today our session starts with the AWS instances and their types. So previously we have seen SNS, it is simple notification service. Then SQS, it's simple queue service. Then SES, it is simple email service. And after that we saw some database instances, some relational database and some non-relational database, some SQL types and the database types that are used in AWS. So I have shown you the videos and I have shared you the videos. Please go through the videos, what has been shared. And today I'll be sharing you this slide and slide on RDS, that is database, and how to create RDS. I'll be sharing to your organizer. So please get those videos and PPTs and go through once. And end of every week or the end of the sessions, completed sessions, will be having a test. So I'll be providing you some questionnaires and you have to answer those questionnaires. So I'll be contacting your organizer on this and I'll be scheduling an exam for all the sessions that I have took. So today we are going into see AWS instance types. So I think you know what is an AWS instance, right? As previous session that has been taken by Ravi, he might have said you what is AWS instance and how to create an instance and how to provision an instance, how to check what types of instance has been provisioned. So these are things that has been already taken. Now and today we are going to see a whole theory part and no practical sessions today, only theory part we are going to see. So we are going into the instance types. I'll start with the slideshow. Hey organizer people, if something went wrong, just ping me and just call me if I'm not reachable. We'll start the session now. Yeah. So once again, good evening to all. So we are going to see the instance types that are provided by or that are given as a service by AWS. So as usual, we'll be calling an instance as EC2. You know the naming convention, I think so you are already aware of the naming convention. It's Elastic Compute Cloud. That is the abbreviation of EC2. The 2 indicates 2 C's there. E is elastic and C for compute and C for cloud. That is EC2. So Amazon is providing many number of instance types. So as you are seeing in the screen, we are having M4, C4, I4, I, D, G, R and T types of instances. So what are these M4 and C4 or L2 or D2 or G2 or R3 or T2? So those are the things that we are going to see in the session elaborately and briefly. So as this picture shows, the Amazon EC2, this is the symbol that is used by Amazon for every instances. Even it is different types of instances, also the same symbol is used. This is a symbolic representation. If a client comes up with a infrastructure map to create an instance, you will be seeing this type of diagrams inside their map. So we'll go to the first type of instance. So at the very first we are going to see this general type. So what is this T2, T1 are all general types of instances, and these are all very small instances used for small functionalities. So let us go into this and dive and have a deep understanding on these things. So T2. So this instance name is T2. T2 is a general purpose instance. The instances are burstable performance instances that provide a baseline level of CPU performance with the ability to burst above the baseline. So what in this line what they are saying is, so these are a baseline level. These are basic level of CPU instances, CPU performance. These instances will have with the ability to burst above the baseline. So, for example, if this instances is having 2 GB or 2 core of CPU, so it can extend it up to 4 cores. So these are the basic instances, and these are some instances under these general purpose comes under free tier. I'll tell you what is free tier. Free tier is nothing but if you are having an account inside AWS, you can provision an instance in T2 Micro. It is a free tier, so you won't be billed or you won't be cost for these instances for some time. So that is free tier. So T2 as unlimited instances can sustain high CPU performance for a long as a workload needs it. So T2 as unlimited instances can sustain high CPU performance. That is, if your CPU performance is very high and the spikes are more, so it can last long as possible. So for most general purpose workload, T2 unlimited instances will be provided ample performance without any additional charges. So in T2, you can have unlimited instances with ample performance without any additional charges. Only the charges that are made by AWS that has been built. If the instance need to run at higher CPU utilization for a prolonged period, it can also do that as a flat additional charge of 5 cents per vCPU hour. That is 5 cents per vCPU is that is a single core and per vCPU 1 hour. So what are the features of this general purpose is high frequency Intel Xenon processors are used in these instances, burstable CPU, governed by CPU credits, and consistent baseline performance. So you'll be having base performance consistently, continuously. So it is a low cost general purpose instant type and free tier eligible. As I said, this is the free tier. So it is eligible for free tier. Balance of compute free tier eligible apart from balance of compute, memory and network resources. If you are using any extra resources, then it will be charged. Or if you are using the predefined resources that are given for a T2 micro or a general purpose instances, then it is free. If you are adding more compute or more memory or more network resources for a free tier instance, then it will be those things will be charged. So that's what we are saying. So we are going to next slide. It's M5. So M5 also comes under general purpose. So M5 instances are the latest generation of general purpose instances. This family provides a balance of compute, memory and network resources, and it is a good choice for many applications. So they're saying it, this family provides a balance of compute, memory. So everything will be balanced in this general purpose instances, whether it can be compute, memory and network resources, and it is a good choice for many applications. So for example, if you are running any applications inside a server, for example, Java is an application applied, or with the Java, you can develop an application. So that application, if it runs on an M5 instance, then that it is this M5 instance is good for many applications. So currently we have lots and lots of lakhs and lakhs of applications inside the market. So if you want to install an application, you can choose this instance. It is a general purpose instance and it is a low cost also. So we are going to see the features. So features is it has a 2.5 GHz Intel Xenon Platinum 8175 processor with new Intel Advanced Vector Extension instruction set. So this is the features. And what are the advantages? So new larger instance size. So M5.24x large. So this is the largest in this section, that is the M5 section. It offers 96 cores of CPUs and 384 GB of memory. So we can think how big the system is. 96 cores of CPU. Currently we are using a normal laptop. In that laptop we have 4 to 8 cores. But this instance M5.24 into large, X large, It's offering 96 cores and 384 GB of memory. Then think about the size of the instances. So EBS optimized by default and higher EBS performance on smaller instances. So what they are telling here is EBS is it's elastic block storage. As I said to you, there is another storage named as simple storage service in AWS. So what is the difference between this simple storage service and elastic block storage is, see, simple storage service is an object-oriented storage. So it is only objects can be stored, and you cannot install a OS or something like that in that. But EBS is elastic block storage. This is a block that can be attached to any instant types. So if you are attaching an EBS, so you can configure and you can keep your files and your OS. But if you are using S3, it's a simple storage service, only you can store object related storage. So you cannot install any applications, you cannot run any applications using S3, but using EBS, you can install and run any applications. Up to 25 Gbps network bandwidth using enhanced networking. So I have already said what is the network bandwidth and the performance. So it is the connectivity, that is the network IOPS, input and output per second. So that is the IOPS, not only for database and for even for the bandwidth is up and down data that are transferred up and returned back. So that is the network bandwidth using enhanced networking. Up to 25 Gbps, it can enhance it. Likewise, HVMs and AMIs, that includes drivers for ENA and NVM. So powered by the new lightweight Nitro system, a combination of dedicated hardware and lightweight hypervisor. So hypervisor is nothing that your virtual machine is the hypervisor. This is the instance, that is the hypervisor. So these are the advantages. And we are going to the next slide. We have saw a general purpose instances. So we are coming up to compute optimized instances. What is this compute optimized? So compute is computation. So how the computation is happening? So for example, you're using a calculator. So in a calculator, we are adding 1 plus 1 or 1 plus 2 or 1 plus 3. So 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, and 1 plus 3 is equal to 4, or 2 plus 2 is equal to 4. So how this happens, and at the back end, some computation is working out. So that is the computation compute. So we are computing or we are calculating something. So in a system, how this computation happens? So this computation happens mainly with the help of the CPU that you are loading inside the system. So as I said, C4 is compute optimized workloads and deliver very cost effective high performance at low price per compute ratio. So these instances are mainly given, or these services are mainly provisioned in AWS for high computational works. So if a CPU is doing the computation, these instances are enhanced or hyped with the help of CPU. So the features what we are seeing is high frequency Intel Xenon E5-2666V3 as well processor optimized specifically for EC2 instances. So they are using this processor, Intel processor, specifically for EC2 instances. Default EBS optimized for increased storage performance at no additional cost. So this EBS optimized is elastic block storage optimized instances. As I said, in the last slide, EBS is elastic block storage where you can install application, you can store any files, and you can run the OS. But in S3, you cannot run OS or you cannot install any applications. So higher networking performance with enhanced networking supporting Intel 82599VF. Requires Amazon VPC, Amazon EBS, and 64-bit hypervisor machines AMIs. So this requires a 64-bit HVM AMIs. So if you are using a 32-bit, then it won't work. You need a 64-bit AMIs to provision this instance using this C4 configuration. So the next slide we are going to see about compute optimized instances But what is the difference is here is the C4 and it is the C5. The C5 are optimized for compute intensive workload and deliver very cost effective high performance at low price per compute ratio. You can see both are same. So what is the difference is the features are the difference here. So there you are using a high frequency Intel Xenon E5-2666 V3 processor optimized specifically for EC2 instances. But here you are using 3 GHz Intel Xenon Platinum processor with new Intel Advanced Vector Extension instruction set. So run each core. So that is each core. How many cores you are provisioning? Those each core will have a 3.5 GHz Intel Turbo Boost technology. But in this thing we don't have that. So new larger instance size. So this is the maximum size of the C5 instance that are available in the market. So C5.18x large. So what this instance offers is 72 cores of CPU and 144 GB of memory, and it can have a network bandwidth of up to 25 Gbps using elastic network adapter based enhanced networking. So EBS is optimized by default, as I said, and requires hypervisor machines AMIs that include drivers ENA and NVMe. So you can ask me what is ENA and NVMe. So in the future or in the future sessions, we'll see what is ENA and NVMe. So these are the C5 instances features and the advantages of using a C5 instances. So next we are going to see memory optimized. So the first one we saw is general instance. So you can use the general instance for any type of small calculations or any small process, or you can use that free time instances as your desktop also. The second one, what we have seen is compute optimized. So as I said, compute for more computation power, people will go to compute optimized instances. Then the third we are going to see, that is memory optimized instances. So what is a memory and what is a compute? So as the memory, the name memory, it says, it tells us the temporary, that is the RAM, read alone memory. So there are difference between RAM and ROM. I'll tell you in the future what is that RAM. RAM is read alone memory and uh, ROM is read only memory. So X1E instances are optimized for high performance databases, in-memory database and other memory intensive enterprise applications. So what is the memory intensive applications? So for example, if some processes are running, for some applications and for some databases, it will come with a predefined structure or configuration saying that you need to configure this much of RAM and this much size of RAM for an application to run. So people who are using those applications or those databases will go into X1E instances. So as I said, it is optimized for high performance databases. For example, Oracle, MySQL or MS or Amazon Aurora or MariaDB, all those are databases. So the high performance database and in-memory databases and other memory intensive enterprise applications. So memory intensive enterprise applications that are example are SAP, HANA server and build suite on HANA server and warehouse on HANA and data mart solutions on HANA on the AWS cloud. So these are some of the applications and databases. So X1E instance offer one of the low priced per GB of RAM along EC2 instant types. So as this statement, it is saying that instances offer you lowest price per GB of RAM among EC2 instances. Among all of the instances, it is coming up with lowest price per GB of RAM. Features: high frequency Intel Xenon E7-8880 processors and one of the lowest price GB of RAM, as I said already, up to 3904 GB of DRAM based instant memory. So up to 3904 GB of RAM is it's a big and a huge amount of RAM that is given to an instance. So normally in our system, our laptops, nowadays it comes with a maximum of 8 to more than 8 GB of RAM. But think of 8 GB of RAM compared to 3000 or 4000 GB of RAM, more or less. SSD storage. So SSD is nothing but solid state devices or drives. So there are different types of drives that are used inside a computer. So one among that is SSD, and we have HDD, a hard disk drive, which have moving parts, and SSD is a solid state drives or devices that doesn't have any moving parts, but it is also used for storage, and EPS optimized by default and at no additional cost. So you can use elastic block storage and SSD to store or to configure OS or to keep an application or to run an application inside these X.E instances. Ability to control process C state and P state configuration on X1E32X large and XLE16X large and XLE8X large instances. So used cases is, so these memory optimized instances are used in examples like, as I said, SAP HANA and memory intensive applications certified by SAP to run next generation business suite S/4 HANA, business suite on HANA, and business warehouse on HANA, and data mart solutions on HANA on the AWS cloud. So in memory optimized, we are going to see the next memory optimized instance, that is X1. So X1 or XL instances are optimized for large scale enterprise class and in-memory applications and offer one of the lowest price per GB of RAM among EC2 instant types. So they're saying the same statement. So memory optimized instances are offered with the lowest price per GB of RAM among all other EC2 instances. If you are choosing a specific resource like memory, like CPU, or storage optimized or something like that, or network optimized, so that specification will be charged less. So that is the main thing in AWS. So here also the GB of RAM per GB is different and GIB is different. I'm sorry to say that. So GIB of RAM among EC2 instant types. Features: high frequency Intel Xenon E7 8880 Haswell processor. So one of the lowest, as they said, one of the lowest price per GB of RAM, and up to 1092 GB of DRAM based instance memory. And it comes with the same advantages as SSD storage and EPS optimized by default at no other costs. Ability to control C state and P state configuration, and the same here. The used cases may be in-memory databases, big data processing engines, Apache Spark or Presto, and high performance computing certified by SAP to run business warehouse on HANA, data mart solutions on HANA, business suite on HANA, and business suite S/4 on HANA. So if you come across big data processing engines, we have Spark, Cassandra, and for example, for data analytics engines like Informatica, Tableau. So Informatica and Tableau are the data analysis tools that are now in a good market inside our industry. So those kinds of basic big data engines or processing engines can be used, and these are preferred by AWS for using those applications. In AWS for using those applications, and even AWS recommends clients to use these types of things to start or use their applications. So the next memory optimized instance we are going to see is R4. So R4 instances are optimized for memory intensive applications and offer better price per GB RAM than R3. So here they are comparing R3 and R4. So what are the features is high frequency Intel Xenon E5 2686 version 4 Broadband processors are used, and DDR4. So there are different types of RAMs that are used. So in the previous one, if you see, there is DRAM. So even before to that, if you see the memory optimized is DRAM. So DDR3 is there, DDR2 is there, and DDR4. This is the latest DDR4 as per AWS that is used. So this memory optimized instances is also used for enhanced networking. So what are the use cases we can see here is high performance databases and data mining analysis. So data mining and analysis is like it is most equivalent to big data nowadays. How they are procuring data and how they are handling and how they are maintaining the data. So all these things comes under analysis, and how to handle and how to procure and how to maintain also comes under analysis and data mining. In memory databases, distributed web scale in memory caches, application performing real-time processing of unstructured big data. So the huge examples are Hadoop. Hadoop is a big data engine, Spark clusters, and other enterprise applications. So which are related to data processing or data mining or big data. So that types of applications can be used inside these R4 types of instances. Then accelerated computing. So accelerated computing and compute optimized both are different. So if you want to keep the compute always in the same power or always in the same um, situation or always in the same configuration, we can use that compute optimized in instances. So for example, if we want 4 cores of CPU, permanently the 4 cores of CPU will be there, and you can always enjoy the processing speed. And if you want 8 GB, the permanently 8 core CPUs will be given to that instances. But what is this accelerated computing instances is? We'll see. So under this accelerated computing instances, P3 instances, P3 are the latest generation of general purpose GPU instances. So GPU is different and CPU is different. So that are CPUs for processing things, and these are for graphics. So for example, what we can say nowadays, people are addicted to some gaming consoles and even PC gaming. So for those types of gamings and for doing EFX works, for example, you can see the films like Bahubali. Almost all scenes they have captured using the effects, EFX. So it's special effects that are given using different kinds of applications. Those applications need a special kind of system, a graphic enhanced system to run. So for those applications, we need these types of accelerated computing instances. So P3 instances are the latest generation of general purpose GPU instances. What are the features that we are going to see inside is up to 8 NVIDIA Tesla V100 GPUs, each pairing 120 CUDA cores and 640 tensor cores. So these are high-level graphical instances where you can develop a graphic scenes or scenarios, or you can use it for gaming purpose. It's which game require gaming or for creating graphics or for visualizing graphics or for doing some big works in CAD, because nowadays AutoCAD also comes with a lot of graphical processing and application. So we need these types of instances for those kinds of works. And high frequency Intel Xenon E5 Broadwell processors are used here. Supports NVIDIA Link for peer-to-peer GPU communication. So peer-to-peer is if you are having two instances, two or more than instances that are having accelerated computing instances. So it is having a link so that these two instances can communicate, or if you want anything to be communicated, that can be done. Provide enhanced networking using elastic network adapter up to 25 Gbps of aggregate network bandwidth within a placement group. So within a group, or if we are adding a peer-to-peer GPU communication, so within that group, if we are adding n number of accelerated compute instances, or for example 5 instances if we are having at different places inside data center, inside a VPC. So you will have a communication between those peers. So those communications can be enhanced using elastic network adapter. So that can be enhanced up to 25 Gbps, so gigabyte per second of aggregate network bandwidth within a placement. Used cases are machine deep learning, high performance computing, computational fluid dynamics, computational finance, seismic analysis, speech recognition, autonomous vehicles, and drug discovery. So drug discovery is nothing but what kind of drugs or medicines, or what is the ratio of medicines that are used. So all those things. Then now we are going with the next set of accelerated computing instances, that are P2 instances. P2 instances are intended for general purpose GPU applications. So previously we were seeing of P3 instances, now we are going to see P2 instances. So these are a general type of GPU compute applications. So it doesn't have that much of computing power, and it has more graphical power compared to computing power. High frequency intense around E5-2686B Broadwell processors are used, and high performance NVIDIA. So what is this NVIDIA? NVIDIA is a graphic chip manufacturing and programming company that gives dedicated GPUs all around the globe. So NVIDIA is mostly into gaming or graphics hardware, so that even if you are going to configure a game in your system or your desktop or your laptop, so nowadays all the games are coming up with the innate configuration and a must-need configuration of you should install a NVIDIA graphics card inside your laptop or your system to run that game. So that is the main purpose of NVIDIA company, to develop a hardware and a software that works one and only and dedicatedly for graphic usage. So high performance NVIDIA K80 GPUs, each with two 496 parallel processing cores and 12 GB of GPU memory. So that GPU memory, CPU memory is different and GPU memory is different. Supports GPU direct for peer-to-peer GPU communication. Is another connectivity for peer-to-peer GPU instances communication. Provides enhanced networking using elastic network adapter with up to 25 Gbps of aggregate network bandwidth within a placement group, and EBS optimized by default at no additional cost. As I said, EBS is elastic block storage optimized. We can optimize, we can add this EBS to this accelerated computing instances. So what are the use cases? Machine learning, high performance databases, as I said, computational fluid dynamics, computational finance, seismic analysis, molecular modeling. So molecular modeling is nothing but different kinds of molecules or that are being used in chemical industry, or for example used in some kind of pharmaceutical industries, how the molecular models are. And genomics is nothing that it deals with genes and DNA rendering and otherwise server-side GPU compute workload. So there are another set of accelerated computing instances. There are G3. So G3 are optimized for graphic intensive applications. So comparatively to all the other things, these are only used for optimized graphic intensive applications. High frequency Intel Xenon E5-2686 V4 Broadwell processors are used. And as I said, NVIDIA, the graphic company, Tesla M60 GPUs, each with 2040 parallel processing cores and 8 GB of video memory. Enables NVIDIA Grid virtual workstation features, including support for 4 monitors with resolution up to 4096 by 2160 resolution, that is the resolution rate. So we can use n number of support, that is four number of monitors at a time. If you have this graphics, you can use 4 monitors with a resolution, monitors in the sense in the screen. So if you are going into the graphical industry or the gaming industry, so people has to work with different scenes and with different monitors. The same scenes, same person will be seen in one monitor, and the next person will be seen in another monitor, and the combination of both will be seen in the third monitor. So for these types of operations, so these NVIDIA Grid virtual workstation features will help. And concurrent connected users. So we have license for concurrent connected users, enables NVIDIA Grid virtual application capabilities for application virtualization, softwares like Citrix, Zenlab Essentials, and VMware Horizon, supporting up to 25 concurrent users per GPU. Concurrent is multiple users. At a time, up to 25 users can use that GPU. Enhanced networking using the elastic network adapter with 25 Gbps of aggregate network bandwidth within a placement group. Model GPUs versus vCPU memory. GPU memory, how the model is GPUs first, so GPU and CPU, following that CPU, GPU memory. So G3.4x large is G3, it shows the GPU, and 4x large is the CPU types. So used cases 3D visualizations, graphic intensive remote workstation, 3D rendering, application streaming, and video encoding and other server-side graphics. Okay, so what is the video encoding? Video encoding and decoding is nothing but if we are using a DTH in your home, that is the dish TV, for example, Tata Sky, Airtel Dish TV, Videocon Dish TV is available in the market. Sun Direct is available in the market. So these are video technologies. So see these to send those signals, we need to encode the video and decode the video. So for those things also these graphic computing instances are used. So the signals, using the signals, the videos are encoded and they are sent through signals. And from one sender end, the videos are encoded and they are sent, and to the receiver end, the videos are decoded and it is broadcasted in your television. So for using those types of things, these accelerated computing instances are used. Then the last type of computing instances is F1 instance. So F1 instance offer customizable hardware acceleration with free FPGAs. So if you are from electronics or electrical background, you may know what is the free programmable gate arrays. So those acceleration field programmable gate arrays are provided. So instant features and instant has a CPU Intel Xenon E5-2686 version 4 Broadwell processor, and this network NVMe is SSD storage, support for enhanced networking. And what are the features of FPGA? As they mentioned FPGA, what are the features of FPGAs? Xilinx Vertex UltraScale plus VU9P FPGAs are used. 64 GB of ECC protected memory in 4x DDR4. DDR4 is one of the latest RAM types that are used. Dedicated PCI Express interface. Approximately 2.5 million logic elements are used. Approximately 6,800 digital signal processing DSP engines are used. So next we are coming with storage optimized. So from the first we are seeing the general purpose instances, T1, M, T instances, M instances. Then we came up with compute optimized C4, C5, C4.4 xlarge, C5.xlarge or something like that. Those are compute instances. Then we came up with X1 instances. Those are memory optimized instances, and R4, R3 or RAM optimized or memory optimized instances. Then lastly, we have seen accelerated computing instances, for example, F1, all those things. Accelerated computing is nothing but the graphics or graphics optimized instances. So now we are came up with storage optimized instances. So what is the storage optimized instances is, we can have these instances dedicatedly to store something, to backup or store a large volume of data and to process those data after the storing. So these are storage optimized instances. So H1 is the storage optimized instances feature up to 16 TB of HDD based local storage. So 16 TB is somewhat, it's very big. So in your laptops, maximum we are getting a 2 TB of hard disk. So if you think 2 TB is more, then compare of 16 TB. So 16 TB is equal to some 1 TB is equal to 1024 GB. So it will be more than 20,000 or 20,000 GBs, so more than that. So it will deliver high disk throughput. High disk throughput is nothing but, what is the throughput is, if you're writing or getting back the data in a hard disk, that is the throughput. And the balance of compute and memory will be done here. So what are the features is powered by 2.3 GHz Intel Xenon E5 2686 processors, code named Broadwell processors. Then the advantages up to 16 TB of hard disk drive storage, high disk throughput, as I said, input and output in the high disk, ENA enabled enhanced networking up to 25 Gbps of data is enabled. Then the used cases. What are the used cases that we can see is map-reduced based workloads, distributed file systems such as HDFS and map R or FS. So network file systems, log or data processing applications such as Apache Kafka and big data workload clusters. These are the used cases. Use cases in the sense where are people or the customers are using these servers for what kind of applications and what kind of processing they are using. So that are the used cases. Then the next is I3 instances. So this instance family provides non-volatile memory express SSD backed instance storage optimized for low latency, very high random input output performance. This is very high input and output performance, high sequential read throughput, and provide high input output at a low cost. So IOPS is sending and getting the data and giving the output, that is the input and output per second at low cost. I3 instances offer the preview of bare metal instant types. So bare metal instant types is nothing that is not a hardwareless instance, that is a VM instance, it is a bare metal. So powered by Nitro system for non-virtualized workloads. That is, as I said, it is not a virtualization workloads, it is non-virtualized workloads that benefit from access to physical resources such as hypervisors or clear containers and custom and business critical applications that have license restrictions. So features are high frequency Intel Xenon E5 2686 Broadwell processor with base frequency of 2.3 GHz, up to 25 Gbps of network bandwidth using elastic network adapter based enhanced networking, high random input or output performance and high sequential read throughput, support bare metal instant types. So as I said, bare metal is without a virtualized server or a virtual server. So everything runs on the hardware with hardware like CPU, GPU, all those things. That will be readily available inside the hardware. To support this bare metal instance review for workload that will benefit from direct access to physical processors and memory. So direct access will be given to physical processors and memory. Processor is nothing but the CPU and memory is nothing but the RAM that you are using. So the next is storage optimized instances is D2 instances. Feature up to 48 TB of HDD. The HDD, as I said, hard disk drive based local storage, deliver high disk throughput and offer the low cost per disk throughput performance on Amazon EC2. Features high frequency Intel Xenon E5 2676 Haswell process, HDD storage, as I said, for up to 48 TB of HDD storage can be done. Consistent high performance launch time. So if you are launching an instance, so every instance will work at the time of launch differently, and or after some time due to high traffic or high processing it may work in a different manner. That is, optimization will be more CPU, so system will become slower and slower. So that is the optimization. So here this instance will give consistent high performance at launch time. So very high performance at the time of launch it will be there, and high disk throughput support for enhanced networking. So if you are storing the data, usually this data has to be replicated or stored in other locations. So for that, what we need, we cannot send the data over wireless communication, because data over wireless communication is very weak and it's very feeble. So what we have to do, we have to connect those systems in one center. if you are having a 48 TB of HDD base local storage server in the other in the other region, if you are having a 48 TB of HDD storage, you need to transfer data only through networking with a wired communication. So that thing will happen here in an enhanced way, if you are replicating the data or if you are storing a backup of it. So use cases are massively parallel processing, data warehousing, MapReduce, Hadoop, distributed computing, distributed file systems and network file systems, as I said, network NTS, log or data processing applications. So the example Hadoop, Spark or Cassandra or something like that, Informatica or Tableau or something like that. So these are the storage optimized instances type. So once again, we'll come up with the types that we have seen so far. So people, if you are getting confused by seeing the naming convention of those instances, I'll say you T is the general purpose instance. So if the instance name that start with T, then it is general purpose instance. So M is a general purpose instance, T and M are general purpose instance. And if you see the naming convention, compute optimized. So C4, keep in mind as C4 as compute optimized or CPU optimized. So C stands for compute. So if it is C, if some instances starting with C4 dot 4x slash, that is a compute optimized instance. Keep in mind C as compute optimized instance. So the C4 or C5 or compute optimized. So if you are coming to memory optimized instance, keep in mind there is a small change here. Instead of keeping M, they have or memory M we can keep, or you can keep RAM as memory R. But people they are kept in XLE instance, that should be a memory type of instance, and XL is a memory instance. And now you are thinking about RAM. So keep R as RAM optimized or memory optimized instance R4. So then we are coming up with a processing optimized, that is the GPU optimized. All GPU optimized instances start with P, either P3, P2, and G. So P and G. So any instance that start with P, either P3 or P2 or G. So you can easily remember that G as graphic optimized or accelerated computing instances. G3 and F1 is also a compute optimized instances. Why they are kept F1 is here they are using FPGAs, feed programmable gate arrays. So they are kept as F. Then if you're coming up with storage optimized, keep the hard disk in mind, and any service H starts with H or D or I, those all are storage optimized instances. So as I said, H is hard disk or D drive, disk or drive you can keep in mind. So those are storage optimized instances. And I is also a storage optimized instances where it is a non-volatile memory express is used. And when you are thinking of keep that I as a storage optimized instance. H, D, and I comes under HDI. So you remember like this, HDI, all these three instances comes under storage optimized instances. The last one, as I said, is D, drive or disk, all those storage optimized instances. So D2 instances reaches up to 48 TB. So in storage optimized, you are giving more importance to storage such as hard disks or SSD solid state devices, and for accelerated computing, you are giving more importance to GPUs, that is graphical user interface. And if we go to memory optimized, you are giving more importance to the number of GB of RAMs that are used inside the instance. And if you are thinking of compute optimized, you are giving more cores of CPU into that instance. So these are the different instance types that are currently available in the market. So each instance types have different symbol. As I said, for M the general purpose, M the first end here and the last end are small instances and general purpose instances. The center you can see the diagram keeping as CPU. This is the CPU or the processor that are used inside the servers. So they kept that diagram as compute optimized and storage input output optimized. So one side data is flowing in right direction and other side data is flowing in left direction. So we can keep as input and output optimized and storage optimized instances. So GPU, they are kept as G, graphic user interface. So and memory optimized, so R3, M2, and these are the things that are used. So a RAM is there, and the smaller instances are T instances. So that's all, guys, for today's class. Thanks for listening throughout the call. So as I said in the starting of the session, after completing more and more topic in the future, we'll be having a small test. So guys who are attending these sessions have to attend those tests. Kindly keep that in mind and just go through the materials that I have provided to organizers. So either you can get it from the people who are organizing this or the people who are responsible for these sessions. So thanks once again, and we'll see you in the next class. Bye guys.